First of all, I would like to remind you folks what we did last time, and that is proof that we actually can use binary code for presenting the alphanumeric information. And if we go for that, I will tell you that alphanumeric information is based on English and Latin language. It's about 256 symbols. This from A to Z, then from A to Z. Big letters 1, 2, 3, and so on. Mathematical symbols, slashes, dot, semicolon, colon, and so on and so on. So this alphanumeric set of characters, if you count them, that will be about 256 different characters. So in the special binary code that actually computer can understand, because computer cannot understand symbols like this. To make it understandable for the computer, we need to make it binary. Binary is system that contain only two symbols, zeros and one. The placeholder that can have 0 or 1 named 1 bit. If we have 8 placeholders, each of these placeholders could be 0 and 1, that will be byte. Bit and byte both are elementary units for measuring information. So if we take, let's say, 1001, 1000, that is a byte, and another one like this, 0010, 0001, is also byte. So question, how many different bytes we can write if we have 8 bit? We can shuffle ones and zeros from 0000 and up to 1, 1, 1, 1, 1, 1, 1, 1. And total amount of these combinations will be 256 combinations. So 1 byte is ideal for the encoding of the set of the characters that is good for English language. So let's say that will be A, that will be B, and so on and so on. One of them will be slash, one of them will be space, and this system of encoding named ASCII code. ASCII code. Now, what is the main feature? 1 byte per character. 1 byte per character, folks. A question on exams could be the book with 170,000 characters being digitized. What is the file size? Easy to calculate. As soon as 1 byte per character, and as this is 170,000 characters, so that will be 170,000 characters. So bytes, because they are the same. Now, people invented better units like 1000 byte, 1 KB, 1 kilobyte, 1 million bytes, 1 megabyte, 1 MB, 1 billion, it is 1 gigabyte, giga, and 1 trillion, 1 terabyte, tera. So according to this, I can say the size of the book will be 170 kilobyte. That is easy to calculate. Folks, unfortunately, the disadvantage of this system of encoding is a limitation in number of combinations. By the way, the number of combinations, folks, if we have number of bits, could be calculated according to formula. Q, number of combinations, quantity of combinations, is equal to n to the power of n, where n is equal number of bit. In our case, 8 bit will be 2 to the power of n, 2 to the power of 8, that will be 256. This formula must be remembered. Folks, if we need to increase number of encoding elements, why do we need it? Because there are other languages. Let's say Russian language, which has kind of unusual symbols like this. Chinese language with hieroglyphical symbols like this. Hebrew language with their symbols. Greek language, and many other languages on the planet Earth. So people who start thinking about internet, they actually were thinking for enhancing the ASCII code, and then they start doing different code. They start thinking that if we make n equal 16, then q will be 2 in the power of 16, which is approximately 65,000 variations. 65,000 variations is good enough to encode such a set of symbols that filled with all languages of planet Earth, like African languages, Swahili, Irbo, Tunisian, and Central African, Congolese, Asian languages like Japanese, Vietnamese, Kampucheese, and all other languages. This encoding system has a name Unicode, and this is 16-bit 2-byte per character. Now question, if I have the same problem like this, 170,000 characters in a book, but book is encoded in Unicode because this is Chinese book. How many bytes it will take in the memory of the computer? If we say here the same amount of bytes, but this 2 bytes per character, 2 byte, so that will be 34,000, 340 bytes. Why? Because it's doubled. It is doubled. Because every character will give you, for encoding, 2 byte. So this Unicode is used for the international communication when we need to encode such unusual symbols like hieroglyphic letters of Japan, Hebrew, Russian, Cyrillic, and others. All of these things story will prove you that binary code is good to represent textual information. Now, what about numeric information? How can we represent the quantities in binary code? By the way, why I spoke about binary code, why I'm speaking about it? Because false computer is electronic device. It's misunderstanding any other information but binary. Insider information is a binary. So we need to think how to represent different human understandable information in binary code. Now, to understand how human information works, we need to first understand the quantity that we have a habit to use in our arithmetic and mathematics. Let's say we put 271. I mean, I have $271. Let's go for this. $271. What is this? It could be 2 multiplied by 100, so I have 100 bills, plus 7 multiplied by tens, plus 1 multiplied by single. This system was not invented at the beginning of human existence. People invented it in the 7th century, and one of them, named Al-Khwarizmi from Middle Asia, actually invented this record using geometry. Geometry like this. 1 has 1 angle, 2 has 2 angles, 3 has 3 angles, 4 has 4 angles, 5, 1, 1, 2, 3, 4, 5. 6 like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. That were ancient way to write down the numbers. Another way, folks, we can rewrite this with exponential record. That will be 271 equal 2 multiplied by 10 in the power of 2. Why 10 in the power of 2? Because 100 is 2 in the power, 10 in the power of 2. So we need to put here positions because this is positional system. And 10 in the power of 2 corresponding here to power of 2. Next will be plus 7. 7 came from here. Multiplied by 10 in the power of 1. Power of 1 came from here. Plus 1 multiplied by 10 in the power of 0. Power of 0 came from here. Why 10, folks? Because that is 10 digits. 10 digits, so the basis is 10. From here, that will be 200. From here, that will be 70. From here, that will be 1. Because any number in the power of 0 is 1 from algebra. So, folks, That is exponential record of quantity for decimal numbers. So we know decimal numbers, we know even the rules of calculation. The rule of calculation is this. I can say the highest digit, 9, plus 1 will be 10. That is the rules of calculations. So when we do calculations, I can say 11 plus 9 will be 1 and 9, 0 writing. 1 goes here. 1 and 1 will be 2. So calculations is available. Now, what about binary code? Can we use binary code for record of quantity? Let's try 10111. How much is this? And that will be binary bin. Let's start with writing positions 0, 1, 2, 3, 4. And as soon as this is only 2 digits, that will be not 10, but that will be 2. 1 multiplied by 2 in the power of 4. You see 4 comes from here, 1 from here. Plus 0, 0 from here. Multiplied by 2 in the power of 3. Plus 1 multiplied by 2 in the power of 2. Plus 1 multiplied by 2 in the power of 1. Plus 1 multiplied by 2 in the power of 0. This is the same like decimal, but instead of 10 is 2. Now let's calculate. 2 in the power of 4. 2 by 2 by 2 by 2. Multiply 4 times, meaning 2 multiplied by 2 multiplied by 2 multiplied by 2. That is 16. 2 by 2 is 4, by 2 is 8, by 2 is 16. 0 multiply will be 0. 1 by 2 square, it's 4. 1 by 2 in the power of 1, that is 2. And that is 1. 16, 20, 23. So that will be 23. Now, folks, as soon as this method is working and I can express and convert binary to decimal, I would like to know, will it work for calculations? Let's make the same way calculations like we did for decimal. So I will say the highest digit, which is 1, plus 1 in binary will be 10. Definitely in binary. I would like to tell you folks 10 is not 10 because 10 in binary it's 2. Very easy to prove. 10, let's put 0, 1, that will be 1 by 2 in the power of 1 plus 0 by 2 in the power of 0, which is equal to. Now, I would like to do a certain thing. I would like to take 10111, which is 23, and add 1 to see what's happening. 1 plus 1, we told about 10. 0 writing, 1 carrying. 1 plus 1, 0 writing, 1 carrying to the next. 1 plus 1, 0 writing, 1 carrying. 1 plus 0, that will be 1, and 1 goes from the top. So let's see. 1, 1, 0, 0, 0 will be equal binary. 1, 0, 1, 2, 3, 4. 1 multiplied by 2 in the power of 4 plus 1 multiplied by 2 in the power of 3 plus, and then other 3 zeros. 0 plus 0 plus 0, because these are zeros. How much it will be? This is 16, this is 8, and we have 24 decimal. Folks, take a look. We use 10111 binary and add 1 in binary and get 11000. When we convert it to decimal, it gave us the correct result. Correct result meaning add 1 to 23 and get 24. So calculations can be done in binary code. Not only record of quantities could be, but calculations also. If we made correctly addition, then we can make subtraction, then we can make multiplication and division. So binary code, which is proved now, is good for calculations on the computer. So now we have binary code for two things, for alphanumeric information and for calculation. Alright, what's next, folks? Next, people told me, computer can make decision. That is a new thing. We didn't speak about it. Computer can make decision. How computer can make decision? For example, you get computer generated letter that says, Dear Leonid Knizhnik, to me, according to our calculations, Department of Social Security would like to inform that you are eligible for receiving a pension. I was very happy, but definitely it's computer generated things. How they calculate that I'm eligible for pension? How they calculate everything that my debt past due or I have premium, I need to know. And I will try to explain it, folks. I'll try to explain. Events. In our life, events are everywhere. Events, it's your desire. Events, it's something happened. Events that somebody told you. So if events A, I don't know what it could be. Like you want to buy a car. If you don't have one, this event can be true or false. True or false. For example, I already have a car. So I don't need another one. And I actually don't have the ability to get one more. So A, I need a car, for my case, is false. For my case, it's false. But for somebody else's case, I know the friend who's looking for minivan because his wife gave a life to new baby. Okay, so they need a bigger car, so he's looking for a car for his life. This event is true. So event is a binary thing that is very connected to the computer. True is 1 and false is 0. Why true is 1 and false is 0? Let me tell you. I would like to say I have $5. So if this is a true, I will multiply it by 1 because 1 is true, and that will be $5, which I already have. If this is a false, I will take $5, multiply it by 0 because false is 0, and that will be converted to 0 because false is eliminated. Lie eliminated everything. So we will speak about true and false as two significant data for logical operations. Logical, folks, they're connected to events and decisions. So let's go for A, which A is event, somebody want to buy a car. B is having money. Also could be true and false. So A is desire to get a car. B is ability to pay for that. And C is to get a car, to buy a car. So folks, let's see what we can do. That could be a table for all variations for this. Total variations will be 4. And we need more here. A, B, and C. If somebody have a desire to get a car, so I'll put 1. And this person has money to get a car. He will go to dealership and get a car. Let's see what's next. Somebody has a strong desire to get a car, but he is a very poor man. He doesn't have money for the car. He will not go anywhere because nobody give him a car. Another situation. Somebody does not need a car. He has one. But he has money for that. Will he go? No. And definitely, if somebody don't need a car and don't have money, he will not get a car. Folks, this operation between two events, they have relationship between. This relationship named conjunction. Conjunction is a logical end. So we can say for these two events, like algebraically expressing it, we can say A and B is equal C. So only when A and B both together are true, then C will be true. This is element of logical algebra. Logical algebra. Logical algebra, folks. Logical algebra was invented by Aristotle in ancient Greece. And then it was mathematical expression of logical algebra. Who made it? Boole. So logical algebra, also named a Boolean algebra. The symbol for operation AND is little birdie, like this. So we can say A and B is equal C. Another expression is A in conjunction of B is equal C. Can we imagine different relationship? Definitely we can. Let's say A is visitation to doctor 1. A to go to doctor 1. B is visitation to doctor 2. Both doctors are accepting my insurance. So I can go to doctor 1 to doctor B. And C is get prescription. So folks, let's make the same table as we did for that. A, B, C. So if I go to doctor 1 and didn't go to doctor 2, will I get my prescription? Definitely, doctor will give it to me. If I go to doctor 2 and will not go to doctor A, I will get my prescription. If I go to both doctors, today to 1, tomorrow to 2nd, I will get even 2 prescriptions, but definitely will get one. And only if I didn't go to neither one, that I will not get a prescription. So folks, let's see relationship between these two events, A and B. At least one is true and the entire result is true. So in this case, both operands. Why I say operands? Because operation, logical operation, is operation between operands. A and B are operands. Both operands must be true. In this case, that looks like disjunction and look like this: A or B or C. The algebraic symbol is like this: A or B is equal C. And this at least one is true. C is true. Disjunction. So folks, that algebraic operations for the events. But you can see events are very relative to binary code. So computer actually can calculate it. And the last one, folks, the last one only has one operand and one result, A and B. This operation looks like this. You say yes, I say no. Okay? So that table will be simpler, A and B. If somebody said you owe me $1,000, you say I owe you nothing. If somebody said this is not your money, zero, you said no, this is my money. You see, it's crisscross, meaning 1 generates 0, 0 generates 1. This is operation no or negation. Negation is look like this: A is equal, no B. That is symbol of negation. So this is opposite. Alright folks, so this is logical operations. Logical operations to make a decision. I will give you one quick sample how computer actually dealing with logical operations. For example, we need to figure out can this person be a driver? Driver is event. So I'll put A is license, B is to have a car, C criminal record, D foreign citizen, A, B, C, D, E blind. That's enough. Let's go for to be a driver is equal A, have a driver license, and B, to have a car, and no C, no criminal record, and no D, and no E. So this binary operation will give you positive result if the person has driver license, has a car, not a criminal, no foreign, meaning United States citizen, and not blind. You see this? No, not blind. So this algebraic formula could be placed in the operational mode of computer processor and could calculate the results for the people. So we can say computer generated decision. Now, folks, the new topic is computer structure. Computer structure. Now, computer started with a storage device because all the data must be stored in some kind of electronic device because we cannot store it verbally like we store it in the brain. So computer must have the device. I will make the picture of it and I will say this is storage. What is the storage? It's like storage for the files, like a flash drive or hard drive, something that remembered my information. Storage could be magnetic, that is hard disk drive. Folks, you please read the article in Blackboard and the picture of magnetic hard drive, or solid state drive, hard disk drive HDD, based on magnetic field. SSD, solid state drive, is electrical field. But both of these devices have the ability to store information. The typical storage capacity is about 4 terabyte for the computer. 4 terabyte. Could be less or more, depending on the price. And the speed of getting this information is quite fast according to the human ability to understand it. To get a file from this storage, you need to definitely understand the file size. But I will say, folks, that the speed of getting information is about 100 megabyte per second. So your laptop, if you have a storage device but you cannot work without storage, actually works with 100 megabyte per second. Now, this data, because the data storage actually storing the data, need to be processed. What is the process? What is the procession, folks? I don't know what we need to do with this data. For example, I would like to detect who from this list of the people who stored in the storage device will get a premium at the end of the year, or who is eligible for pension, who must be mobilized in United States Army, and so on. So that is a processor unit. Processor named MP. Abbreviation is MP because it's microprocessor. Microprocessor cannot work directly with the storage because they do not direct interface. Interface is the way of communication. Interface. It's a standard of communication. Why they don't have direct interface? Because microprocessor work much faster than MP, than hard drive. So to get access to the data, microprocessor must have the middleman. The middleman named bus. Why it's named bus, folks? Because bus is transportation unit for information. It is transporting data to the hard drive and from hard drive. So this is a data track, and microprocessor has its own data track to bus. So communication looks like this. Microprocessor asks bus, digitally of course, bus, can you bring me a data file named Leonid Knizhnik dossier? And then bus will tell storage will find this data, and data will go to microprocessor. But microprocessor does not have fast memory like we have. We have a memory to calculate something because fast memory that I made operation and forgot. So we need to have a memory for the microprocessor, and this memory named random access memory. RAM, random access memory. Why is it named random? Because memory is a table. Memory is a table. Every cell of the table could be 32 or 64 bit. 32 or 64 bit. So that is 4 or 8 byte. And this cell has address. Address is a number of cell in this table. How many byte this memory could have in a contemporary computer? Folks, yesterday I actually increased memory of my computer that I use now to communicate with you, and now it has 32 gigabyte for the memory. I will show you folks memory if I have it on me, on my possession. I don't believe I do. Hold on a second. No, I don't see it. Um, Next time I will show it to you. But folks, this is an electronic device, no movable part, and it will go to the motherboard because everything that you can see here is motherboard. Motherboard, folks, is communication board where everything and anything connected. Definitely RAM must be connected bidirectionally to the bus. What RAM actually used for? RAM used for data that came from hard drive storage, and RAM used for programs. Programs. What is a program? Program is set of instructions. Set of instructions. Folks, what instructions? What kind of instructions? Instructions because microprocessor has ability to process data, but it doesn't know what to do. So it is capable to do things, but what to do in a sequence of operations, he cannot take anywhere but from memory. Who put this program, who put this sequence of operations for processor into memory? I will tell you folks, that is a profession named programmer. Programmer. This is people who are doing it, who create applications for the computers. Okay, now we have this kind of device connections, and we need to see what processor doing. What processor doing, we will see just like this. This is a monitor, and this is adapter, VGA. What is VGA, folks? Visual Graphic Adapter. That is visual graphic adapter, and MON is a monitor. Visual graphic adapter is needed because bus, RAM, processor, and storage speaking in the terms of binary code. But monitor is just a TV. So to convert information from binary code to the graphical equivalent, we need adapter, converter. And we will study how this converter works. Okay, then folks, we will go for other convenient things. We need to have keyboard. Keyboard is input device. We need to have mouse, which is pointing device. We need to have USB port. And what else we need to have? Which will be network adapter. Bidirectional, and this is cable or Wi-Fi. So folks, that is computer. That computer already works on this paper. But this is only problem. Processor need a program to start get program from the storage. From the beginning, memory is empty. Without electricity, memory is zero. So when you turn on the electricity, this computer will not start because microprocessor need instructions, how to put instructions in a memory. Instructions to get instructions. So folks, to get over these limitations, people in the factory, they put the microchip named BIOS. BIOS is initial program. And this initial program will go directly to memory when you turn on the computer. And then microprocessor will be informed by bus that the first program is load in memory, and microprocessor start doing this program one operation by one operation. That is how computer works, folks. Definitely in a certain level of working, microprocessor will give command to the bus to load operating system. Load or boot OS, operating system. It could be Windows operating system, it could be Macintosh operating system, any operating system, but without operating system, computer is brick. It will not work. Operating system create interface named graphic user interface, GUI. This is graphic user interface that you use on telephone, Android, that you use on iPhone, that you use on any computer. Interface is graphic user interface.